Hello, 11th graders. So I have realized that there's been a big lack in participation recently, and I don't know if it's coming from confusion or if it's coming from just burning out. We've talked about it a little bit already in our previous lesson, but this is one thing that reaching out to a couple of you seemed like maybe was a good option, was to have just a review session just about trigonometry. I think a lot of you guys are feeling a little lost with trigonometry. Which is very normal. Geometry is a very different type of mathematics from all the other mathematics. And so I'm sure for some of you, it's just really clicking and you get it and you understand it and you might even like it. Crazy. But I know probably for some of you, it's a little bit frustrating. So totally normal. It's a very polarizing mathematics. So definitely normal that you might feel differently than your peers about it. But this is just going to be a review session about trigonometry. So we've got quite a few formulas that we learned, and we've got a couple processes that we've learned that we've really got to move on and understand it. And we have to understand it, feel confident in it, and move on. So we're going to talk about the formulas, the different processes, and just have it as a list there available to us of what we're supposed to know by this point. And then we have a couple of examples to go through. And I'm trying to make sure that your notes aren't too long, so I'm going to try and speak fast. All right, so at the very, very beginning of our trigonometry section, which was 5.2, we talked about Pythagorean theorem. That should be something that you feel pretty confident with at this point. If you do not, definitely let me know or do some research. Pythagorean theorem is c squared equals a squared plus b squared. That is our Pythagorean theorem. It's only used for right triangles, and c is the hypotenuse. So any of those things that I just said, even though I'm not writing it down, you are more than welcome to write it down of like, okay, this is for right triangles. I would definitely, like, you could even put a little symbol to the side of it that says it's for right triangles, yeah? Because we have some formulas that can only be used with right triangles. Next, what we're going to talk about is your SOHCAHTOA that we learned about. SOHCAHTOA is that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. This again is only for right triangles. You can use it to solve for angles, or you can use it to solve for side lengths. If we use it to solve for angles, we just have to make sure that we're using our inverse trigonometry at the end of the process. But those are formulas that we've learned. The next thing that we have learned is the law of sines. The law of sines is that the sine of any angle divided by its opposite side is equal to the sine of any other angle divided by its opposite side. This is for any triangle. So I'm just going to draw a triangle that does not look like a right triangle, or maybe it does, but I'm not going to put here, I'll draw it so it doesn't look like a right triangle. So this is for any triangle. It does not have to be a right triangle, but it does work for right triangles. So you can use it for right triangles, but you do not have to use it for right triangles. The next one is your law of cosines. Your law of cosines is lowercase c squared equals a squared plus b squared minus 2ab cosine of uppercase c. This is also for any triangle, not just right triangles. It could be for any triangle. Oh, I gave you way too much space. Maybe you guys will use the space though. All right, and our last one is your area formula. Area of a triangle. This is your trigonometry way to do it. A equals 1/2 lowercase a, lowercase b, and then sine of, I'm going to do C instead of theta because now we're starting to get used to the fact that A, B, and C uppercase letters are all the vertices of our triangles, and then all the lowercase letters are all the side lengths that are opposite of it. So notice that if we're talking about lowercase a and lowercase b, we're talking about any two side lengths, but then uppercase C would have to be the angle between those two side lengths. Okay, those are, that area of the triangle works for any triangle as well. So we do not specifically have to have a right angle going on here in order to be able to use that. Some of these are in your formula packet and some of them are not. The law of sines is in your formula packet. Law of cosines is in your formula packet, and the trigonometry area is in your formula packet. The ones that are not are your Pythagorean theorem and SOHCAHTOA. Those are not in your formula packet. You have to just know those. All right, processes. Some processes that we have learned are solving for side lengths, solving for missing side lengths. I will not write this down because my stylus is driving me crazy, but you should write down what that process is. The process is that you have to set up a formula and then solve for the missing side length. It's super easy. Obviously, some of these other ones are going to get a little bit more tricky, but your first step is to find the right formula such that there's only one variable and then solve. The next process that we learned was solving for missing angles. So this is just a little bit more complicated because we still have to set up our formula, but then we have to use our inverse trig for some of them. Inverse trig functions, that's your like sine to the -1 guy. In order to solve for that. Or you can use your calculator and use your numerical solve, which is on the TI Inspire, or graph and find the intersection with your TI 84s. But if you're doing it algebraically, you need to use your inverse trig functions. All right. And then the other main processes that we learned were your angle of elevation and angle of depression. I've been seeing a lot of inconsistencies with your understanding with this. Just to reiterate that your angle of elevation, so I'm going to do E for elevation. If this is the person, you need to build your horizontal line of sight and then the line of sight up, and that is your angle of elevation. Versus your angle of depression, D, is going to be, again, building out that horizontal line and then down from there. That is your angle of depression. You might be using right triangle trigonometry, so your SOHCAHTOA stuff, or you might be using law of sines and cosines. You have to build the diagram first and then see, is this a right triangle or is this not a right triangle? And then how do you go about doing that? Last thing or process that you should be feeling comfortable with by now, and if you're not, hopefully by the end of class you are, is bearing. So bearing is this idea of having a point and then having this due north and then an angle that comes out from it. Right? So if this is due east, then this guy would be your bearing, right? So like that might be a bearing of 70 degrees. If you have something more than 90, you're going past 80 degrees. So let's do all the different examples. So we'll call this B. Still talking about due north. Here's our east. If we had an angle that was greater than 90, it would come down to here. And that would be that. And that's between 90 and 180. So this situation for this first example is between, so theta lives between 0 and 90 degrees. Here, theta lives between 90 and 180 degrees, if they're in that quadrant. 180 degrees, so this is our third example. We'll call it C this way. This is due south. This is due east. So having an angle that comes out this way, we would have to be greater than 180 degrees. We would have to be between 180 and if this guy is due west, that's 270. So this is an angle that lives between 180 and 270. And then our last example here's due north, here's east, here's south, here's west. If we have an angle that peels all the way around to here, it's a big angle. That angle would live between 270 and 360 degrees. So that's kind of the idea of building your bearings. We also deal with parallel lines. So a real quick reminder about parallel lines.